Good morning. Welcome to TMMS Productions. Today we are going to solve Science Paper 1, that is Physics paper of 2019 ICSE Board Examination. The paper consists of Section 1 of 40 marks, which is compulsory, and Section 2 also of 40 marks, which has 6 questions. From these 6 questions, you have to attempt any 4. So ideally, during your reading time, you should read Section 2 first and decide upon the questions you will be attempting and plan your answers accordingly. Let us look at our paper. It's Physics, Science Paper 1, and it is for 2 hours. So ideally, 1 hour for Section 1 and 1 hour for Section 2. During your reading time of 15 minutes, choose the questions very carefully from Section 2, then come to question 1 of Section 1 and start reading it very carefully and decide upon how you will plan your answers. So, Section 1, which is compulsory, it will have 4 questions. Each one will have 5 subparts, A, B, C, D and E, and each one of them will be for 2 marks. Now let us go quickly to question 1. A. The diagram shows a claw hammer to remove a nail. To which class of lever does it belong? Now here the nail, which is going to be your load, and your effort is going to be applied here, and so we have this is the fulcrum over here, so you will have fulcrum between load and effort, so it will be class 1 lever. Give one more example of the same class, which means class 1 lever, for which the mechanical advantage is greater than 1. Now, mechanical advantage greater than 1, ideally you could just write your metal cutter, because it will have mechanical advantage greater than 1. We come to question B. Question B, 2 bodies A and B have masses in the ratio 5:1 and their kinetic energies are in the ratio 125:9. Find the ratio of their velocities. So we'll make the 2 columns for A and B body, and we'll call this mass as M1 5m and M2 as m, because mass ratio has been given as 5:1. And kinetic energy 1 is to kinetic energy 2 is 125:9. And so we will write KE1 is to KE2 is equal to 125:9. Therefore, half M1V1 square is to half M2V2 square is equal to 125:9. Now we'll substitute. M1 is 5m, V1 square is to m into V2 square is equal to 125:9. M got cancelled, therefore 5 V1 square, I'm writing upon V2 square, is equal to 125/9, and therefore we will have V1 square upon V2 square is equal to 125/9, and 5 comes from here this side, so it will divide 5 ones and 5 25s, and therefore V1 upon V2 is going to be equal to under root 25/9, which is equal to 5/3, and therefore we will have V1 is to V2 is going to be equal to 5:3, and that is our answer. We come to 1C. Name the physical quantity which is measured in calories. Now calories, it is energy, but you must also mention over here that it is heat energy. How is calorie related to the SI unit of the quantity? Now SI unit is joule, and so 1 calorie is equal to 4.2 joule approximately, which is equal to 4.186 joule accurately. That's our answer. Question 1D. First subpart, define couple and state the SI unit of moment of couple. So our definition of couple: two equal and opposite parallel forces not having the same line of action constitutes a couple. The SI unit of moment of couple is Newton meter. Then we come to E. First one says define critical angle and state one important factor which affects the critical angle of a given medium. The definition of critical angle: it is the angle of incidence in the denser medium for which the angle of refraction in the rarer medium is 90 degrees. The important factor on which critical angle of the given medium depends: temperature. As the temperature increases, critical angle also increases. Now we'll come to question number 2. A. An electromagnetic radiation is used for photography in fog. Identify the radiations. It will be infrared radiation. Why is this radiation mentioned by you ideal for this purpose? It is ideal for the purpose since infrared radiations have the longest wavelength, hence not scattered much and are able to penetrate through the fog. Hence, photography in fog is possible. Question 2B. First part. What is the relation between refractive index of water with respect to air and the refractive index of air with respect to water? They are asking us to find the relation between A mu W and W mu A. And so our answer is A mu W is equal to 1 upon W mu A. Let us come to the second subpart. If the refractive index of water with respect to air, A mu W is 5 upon 3, calculate the refractive index of air with respect to water, which is W mu A. So, we will write W mu A will be 1 upon A mu W, which is 1 upon 5 upon 3, which is equal to 1 into 3 upon 5, which is 3 upon 5, which is 0.6, and that is our answer. Let us look at 2C. The specific heat capacity of a substance is 3800 joule per kg per Kelvin, and that of a substance B is 400 joule per Kelvin kg per Kelvin. Which of the two substances is a good conductor of heat? Give reason for your answer. So we write the answer that B is a good conductor of heat as each kg of it absorbs 400 joules of heat energy to raise its temperature by 1 Kelvin compared to 3800 joules by A. Let us come to question 2D. A man playing a flute is able to produce notes of different frequencies. If he closes the holes near his mouth, will the pitch of the notes produced increase or decrease? Give reason. So, on closing the holes near his mouth, the length of the air column increases and the pitch is going to decrease because it decreases the frequency, and the pitch of the note will decrease because the frequency is inversely proportional to the length of the vibrating air column. Let us come to E of question 2. The diagram shows a light source P embedded in a rectangular glass block ABCD of critical angle 42 degrees. Complete the path of the ray PQ till it emerges from the block. So you will see that this is 42 degrees. So now we have to draw the normal at Q in order to understand the path of the light. So we shall draw the normal like so. So now this one is your angle of incidence. This will be 90 degrees minus 42. That will be 48 degrees. And so the ray of light will undergo total internal reflection like so. So this angle also will be 48 degrees. This will be 42 degrees. This is 90 degrees. This will be 48 degrees. And now it is again going from denser to rarer. So again we will check how much is the angle of incidence by drawing a normal. And this angle will be 42 degrees. Now this 42 degrees is equal to the critical angle. And so we would be having the ray emerging along the glass air interface, and this will be 90 degrees, which will be the angle of refraction, and that would be the path of the ray. Let us come to question 3A, first part. If the lens is placed in water instead of air, how does the focal length change? The focal length increases. And which lens, thick or thin, will have greater focal length? It will be the thinner lens has greater focal length. We have 3B. Two waves of the same pitch have amplitudes in the ratio 1:3. What will be the ratio of their intensities? Now we know that intensity is directly proportional to the amplitude square. Therefore, I1 upon I2 will be equal to A square, A1 square upon A2 square. And so, if our original is A and the final is A2, which will be 3A, I will write it as A square upon 3A whole square, which will give us A square upon 9A squared. A square gets cancelled and 1 upon 9. And so the ratio of intensities will be equal to 1:9, and that is our answer. Now they are asking us the ratio of their frequencies. They have the same pitch, so the ratio of frequencies is going to be 1:1 since the pitch is same. Let us come to question 3C. How does an increase in temperature affect the specific resistance of a metal and a semiconductor? For the metal, the specific resistance increases with increase in temperature, but for semiconductor, it remains constant with increase in temperature. Question 3D, first subpart, define resonant vibrations. Second part, which characteristics of sound makes it possible to recognize a person by his voice without seeing him? The resonant vibrations. The resonant vibrations are formed when the frequency of the externally applied force equals the natural frequency of the body, and this body will now execute resonant vibrations. Now we come to the second part. Without looking at the person, how will we recognize the person? Which is the characteristic? It is quality or timbre. That's the characteristic of the sound. We come to 3E. Is it possible for a hydrogen 1,1 nucleus to emit an alpha particle? Give a reason for your answer. So we write, an alpha particle is made up of 2 protons and 2 neutrons. Hydrogen nucleus H11 has only 1 proton. Hence, it is not possible for it to emit an alpha particle. We come to question 4A. Calculate the effective resistance across AB. Now we draw the diagram on our paper, and now we look at the direction of the current. If we pass the current from A, it will go into 2 branches. This will be one branch, so we will have this in series, so I'll call that as RS, and then this RS and this will be in parallel. So we write 5 ohm and 4 ohm are in series. Therefore, RS is equal to 5 ohm plus 4 ohm, which is 9 ohm. Now, RS and 3 ohm are in parallel. Why are they in parallel? Because they are in 2 branches, this one and this one. And so, we will say 1 upon Rp is equal to 1 upon Rs plus 1 upon 3, which is equal to 1 upon 9 plus 1 upon 3. That gives us LCM 9. And therefore, we will have Rp equal to 9 upon 4. 4 2s 8 and 1/4 means 2.25 ohm. Now this is your Rp. What is your Rp? Rp is this. Now equivalent resistance will be 8 ohm plus Rp. So we shall write that. Therefore, equivalent resistance between A and B is going to be equal to 8 ohms plus Rp, which will be 8 ohm plus 2.25 ohm, which is 10.25 ohm, and that is our answer. Question 4b. State whether the specific heat capacity of a substance remains the same when its state changes from solid to liquid. Does it remain the same? No. It differs. Give one example to support your answer. Let us take a simple example of ice becoming water, because solid state ice is going to become water in liquid state. So we'll say that SHC of ice, that is the solid state. It is 2.1 joule per gram per Kelvin, which is 2100 joule per kg per Kelvin. But SHC of water, when it is in liquid state, it is 4.2 joule per gram per Kelvin, which is equal to 4200 joule per kg per Kelvin. And so we see that the specific heat capacities are not the same, they differ. 4C. A magnet kept at the center of two coils A and B is moved to and fro as shown in the diagram. The two galvanometers show deflection. Now let us look at this. This is your coil A with galvanometer showing X as the reading, and here is another coil, coil B, with the galvanometer showing reading Y. Now if this magnet is moving to and fro, it is going to induce EMF in this as well as this coil, and state with reason whether X is greater than Y or X is less than Y, means the deflection of galvanometer in A in X and deflection in galvanometer Y. Which one will be greater? Now we know here there are less number of turns, here there are more number of turns. So we are going to say, since there are more number of turns over here, we will say that Y is going to show greater deflection than X, which means X is less than Y, since greater EMF is induced in coil having more number of turns. And we will also mention that EMF induced is directly proportional to the number of turns of coil. Let's come to D. First subpart. Why is a nuclear fusion called as a thermonuclear reaction? And then complete the reaction, and they have given the reaction like so. The nuclear fusion reaction takes place at a very high temperature, approximately 10 to the power 7 Kelvin. Thus, both light nuclei acquire sufficient kinetic energy due to the thermal agitation to overcome the force of repulsion between them, and they get fused. Hence, it is called as thermonuclear reaction. Complete the reaction. Helium 3,2 plus hydrogen 2,1 will become helium 4,2, and one particle will remain here, so that becomes hydrogen 1,1 plus energy, and that is 18.3 MeV. We come to 4E. State two ways to increase the speed of rotation of DC motor. Number one, by increasing the current in it, and the second one by increasing the number of turns in the armature coil. So that finishes our section 1. That was the compulsory section. Now section 2, which is of 40 marks, we will be having 6 questions, and each one of them will be having marking scheme 334 more or less, and we have to attempt any 4 questions. So let us look at question number 5. A body of mass 10 kg is kept at a height of 5 meter. It is allowed to fall and reach the ground. What is the total mechanical energy possessed by the body at the height of 2 meter, assuming it is a frictionless medium? And what is the kinetic energy possessed by the body just before hitting the ground? And G is given as 10 meter per second square. Now in our solution, we'll write mass is 10 kg, height is 5 meter. So the maximum height is 5 meter. Now we are being asked the total mechanical energy at height 2 meter. Now at 2 meter, when it is freely falling, it will have some kinetic energy and some potential energy. But the total mechanical energy will be equal to the initial potential energy, and that will be according to law of conservation of energy. And so we will write it as mgh, that is 10 kg multiplied by 10 meter per second square multiplied by height is 5 meter. And that gives us 5 into 100, that is 500 joule. So this will be the total mechanical energy possessed by any body at any instant. And that is your first answer. Second part is what is the kinetic energy possessed by the body just before striking the ground. So we will write kinetic energy just before striking the ground will again be equal to initial potential energy, and again according to law of conservation of energy. And so we have already found that out, which is mgh, and that will be 500 joules, just as we have calculated in the first subpart. And that's our answer 2. Question 5b. A uniform meter scale is in equilibrium as shown in the diagram. So you will see 0 centimeter, 100 centimeter, that is the meter rule, and the fulcrum is at 30 centimeter, and from 5 centimeter 40 GF has been suspended. Calculate the weight of the meter scale, and which of the following options is correct to keep the ruler in equilibrium when 40 GF weight is shifted to 0 centimeter mark. So in the second part, we are shifting this 40 to 0 centimeter instead of 5 centimeter. F is shifted towards 0 centimeter or F is shifted towards 100 centimeter. Let us see how we do this. So I have drawn this diagram here. This is the meter rule, which is 0 to 100. At 5 centimeter mark, we have got 40 GF, and 30 centimeter is where the fulcrum is placed. Now, we have to find the weight of the meter ruler, which is going to act from the center of gravity, which is 50 centimeter. So we will call that as mgf. As a result of that, we will see this is the anti-clockwise moment and this is the clockwise moment over here, and we will have from here to here, this is going to be our L1. This becomes our W1. Then from here up to here, this becomes your L2 and MGF becomes your W2. How much is this distance over here? L1, 30 minus 5. So that is our 25 centimeter. L2 is from here to here, that is 50 minus 30, which is 20 centimeter. And so we are going to write at equilibrium according to the principle of moments, sum of anticlockwise moments is equal to sum of clockwise moments. And so we will have W1 L1 equal to W2 L2. Let us substitute. W1 is 40 GF multiplied by L1 is 25 centimeter, which is equal to MGF multiplied by 20 centimeter. And so we will have MGF will be equal to 40 GF multiplied by 25 centimeter divided by 20 centimeter, and that gives us MGF to be 25 into 2, which is 50 GF, and that is the weight of the ruler. That is our answer 1. On shifting 40 GF to 0 centimeter, we will have the moment due to 40 GF, and that would be 40 GF multiplied by 30 centimeter, which means it will become 1200 GF centimeter, and that would be anti-clockwise. Now earlier moment was 40 multiplied by 25, which was 1000 GF centimeter, and so now anti-clockwise moment has become more. So we will write that since anti-clockwise moment is more, because from 1000 it has become 1200 GF centimeter, and therefore to increase the clockwise moment we will have to increase this distance, and so F should be shifted towards 0 centimeter mark, and that is our answer 2. Let us come to question 5C. It's again a diagram. The diagram shows a pulley arrangement. So you can see pulley A and pulley B. This is the load and this is the effort. Copy the diagram and mark the direction of the tension in each strand of the string. Now here, this T will be the same as E. This one also will be tension, and this also will be tension. All three tensions will be the same. So that answers our first part. What is the velocity ratio of the arrangement? Now the velocity ratio of the arrangement is going to be because of the single movable pulley, and so we will write velocity ratio of this is going to be 2, since dE upon dL will be equal to 2x upon x, which will be equal to 2. If the tension acting on the strings is T, then what is the relation between T and effort E? Now, magnitude wise, your T is equal to E. But if you look at the tension T, as a vector quantity and effort as a vector quantity, then this will be vector t is equal to minus vector e. If the free end of the string moves through distance x, find the distance through which the load is raised. Now, the free end of the string moves through distance x, which means your displacement of effort is going to be x. And now they are telling you find the distance through which the load is raised. So displacement of load is equal to question mark. We have our velocity ratio formula dE upon dL. And therefore velocity ratio is 2 is equal to dE, which is x, upon dL. And therefore displacement of the load is going to be equal to x upon 2, and that would be our answer. We now come to question 6a. How does the angle of deviation formed by a prism change with the increase in the angle of incidence? So we write the answer. As the angle of incidence is increased, the angle of deviation decreases. This continues up to a point when, on increasing the angle of incidence, the angle of deviation starts increasing instead of decreasing. And our question says, draw a graph showing the variation of angle of deviation with the angle of incidence at the prism surface. So here we have y-axis, x-axis, delta, that is angle of deviation, which is along y-axis, and angle of incidence is along x-axis, and this is the variation where we have the lowest value of delta, that is angle of deviation, denoted by delta minimum. Question 6b. A virtual diminished image is obtained when an object is placed between the optical center and the principal focus of a lens. Name the type of lens which forms the above image. Now, virtual diminished is possible only with a concave image. So, name the type of image. So, that is our concave lens. Draw a ray diagram to show the formation of the image with the above stated characteristics. So the object is placed between optical center and the principal focus. So here we have the diagram. This is our principal axis. This is our concave lens. We have marked F2 and F1, 2F2, 2F1, and according to the question, we have shown an object between O and F. The first ray goes parallel to the principal axis and it diverges, appears to be coming from F2. Second ray goes through the optical center where the two appear to be meeting. That is where we have the image formed. We will call that as A dash B dash, and then we will mention out here AB is the object, A dash B dash is the image, and we'll mention the characteristics of the image. Number 1, it is virtual. It is number 2, diminished. It is upright, and it is between the object and the lens. Question 6c. An object is placed at a distance of 24 cm in front of a convex lens of focal length 8 cm. So we have the object distance 24 cm given and the focal length is 8 cm. What is the nature of the image so formed? Now, the focal length is 8 cm and the distance is 24 centimeters, which is much beyond 2f, which means it's going to give you a real image. Calculate the distance of the image from this lens and calculate the magnification of the image. So let us look at our solution. We have the object distance minus 24 centimeter because the object is in front, it will be having minus sign. focal length is plus 8 centimeter because it's a convex lens. They are asking us what is the nature of the image. It is real because the focal length is 8 and this u, that is object distance, is more than 2f away. The distance more than 16 centimeters away, and so is going to form a real diminished image. The second part asks us to find the distance of the image from the lens, that is v equal to how much. So we write our formula 1 upon f is equal to 1 upon v minus 1 upon u, and so 1 upon 8, which is the positive quantity, is equal to 1 upon v minus 1 upon minus 24. And now 1 upon 8 becomes 1 upon v plus this minus and this minus becomes plus 1 upon 24, and then we will take 1 upon v one side and transfer 1 upon 24 to the other, so it becomes 1 upon 8 minus 1 upon 24. The LCM 24 will give us in the numerator 3 minus 1, which is 2. So 1 upon v turns out to be 2 upon 24, which is 1 upon 12. That gives us 1 upon v equal to 1 upon 12, and the object distance when it is 24, the image distance is 12 centimeter, and that is our answer. The third part tells us to find the magnification. Now magnification is size of the image upon size of the object, which is the same as image distance upon object distance, that is v upon u. So we substitute v as 12 centimeter, u as minus 24 centimeter, got cancelled, and then 12 ones and 12 twos, that gives us half with the minus sign. That is our magnification, and that is our answer. Question 7. A. It is observed that during the march past, we hear the bass drum distinctly from a distance compared to the side drums. Name the characteristic of the sound associated with the above observation, and the characteristic is loudness. Give reason for the above observation. We will have the bass drum has larger area of drum surface set into vibrations. This increases the intensity hence the loudness. Question 7b. A pendulum has a frequency of 4 vibrations per second. An observer starts the pendulum and fires a gun simultaneously. He hears the echo from the cliff after 6 vibrations of this pendulum. If the velocity of sound in air is 340 meters per second, find the distance between the cliff and the observer. Now, we have been given that 4 vibrations are going to take 1 second. So we are going to write 4 vibrations take 1 second. So 6 vibrations will take 6 upon 4, which is 3 upon 2 second. Therefore, our time is 3 upon 2 second. The velocity is 340 and we have to find the distance. Our relation between the velocity and the distance is v is equal to 2d by t. And so we are going to write, therefore, D is equal to Vt upon 2. Now, the distance will be, velocity is 340 meter per second, multiplied by time is 3 upon 2 second, and we are dividing by time, so I am putting like so. So 2 ones and 2 goes here 170 times, 2 ones and 2 here goes 85 times. So we will have 85 multiplied by 3 meters per second. Second gets cancelled. 3 5s 15, carry 1, 3 8s 24 and 25. So 255 meters is the distance between the cliff and the observer, and that is our answer. 7C. Two pendulums C and D are suspended from a wire as shown in the figure given below. Pendulum C is made to oscillate by displacing it from its mean position. It is seen that D also starts oscillating. Let's look at the diagram. This is C and this is D. C is made to oscillate by displacing it from the mean position. This also starts oscillating. Number 1, name the type of oscillation C will execute. So C will execute the damped vibrations or oscillation. Name the type of oscillation D will execute. Now D is going to vibrate under the influence of C. So D will execute forced vibration or forced oscillation. If the length of D is made to be equal to that of C, then what difference will you notice in the oscillations of D? So your D oscillations will be, they will have larger amplitude and will be in same phase as C, and this will be due to resonance. What is the name of the phenomenon when length of D is made to equal C? And that will be resonance. Question 8a. Write one advantage of connecting electrical appliances in parallel combination. The advantage is each appliance gets connected to the same voltage rating or the supply, that is 220 volt for its working. What characteristic should a fused wire have? Fused wire should have, number 1, high resistivity, and number 2, low melting point. Which wire in the power circuit is connected to the metallic body of the appliance? It is the earth wire which is connected to the metallic body. Let us come to 8b. The diagram below shows a dual control switch circuit connected to a bulb. So we have a bulb here and then we have these two switches. Copy the diagram and complete it so that the bulb will be switched on. Now I'm not going to copy it once again. I'm going to make the change here itself. I'm going to connect this, and so this will be your live, this will be your neutral, and the current is going to go this way and the bulb is going to glow. Out of A and B, which one is the live wire and which one is the neutral wire? So we've already written over here, A is live wire and B is neutral. wire. Question 8c. The diagram above shows the circuit with key open. This key is open. Calculate the resistance of the circuit when key K is open. Now when key K is open, the current will not flow here, but it will go through this. And so the resistance of the circuit is going to be is going to be 5 ohm plus the internal resistance here 0.5 ohm, which is equal to 5.5 ohm. And that's your answer 1. The current drawn from the cell when the key K is open. Now when we have to talk about the current drawn from the cell, we have to use the formula I is equal to E upon R plus R. So EMF is 3.3 volt divided by R plus R. This is your R plus R, so which is 5.5 ohm. And so it is going to give us 33 upon 55, 11 threes and 11 fives, and so it will be 0.6 ampere. And that's our answer 2. The resistance of the circuit when key K is closed. Now when key K is closed, 2 and 3, they are going to be in series. And so let us show it over here. The third subpart, 2 ohm, 3 ohm are in series. Therefore, RS is equal to 2 plus 3, which is equal to 5 ohm. Now what we will do is we will put this like so, and we will write that this is RS. Now RS and 5 ohm are in parallel. And therefore 1 upon Rp is equal to 1 upon 5 plus 1 upon 5, which is 2 upon 5. Therefore Rp is equal to 5 upon 2, which is 2.5 ohm. Now total resistance in circuit would be now Rp plus small r, which is 2.5 ohm plus this, which is small r, 0.5 ohm, and that will come to 3 ohm. And that is our answer 3. Let us come to the fourth subpart. The fourth subpart, the current drawn from the cell when the key is closed. When key is closed, the resistance is 3 ohm. So we will say I is equal to E upon R plus R, and that will be by Ohm's law. And so EMF is 3.3 volt upon R plus R is this, because external resistance is 2.5, internal is 0.5, so it will become 3 ohm, which will be equal to 1.1 ampere, and that is our answer 4. Let us come to question 9. Define calorimetry. Now calorimetry, it is a branch of physics which deals with the measurement of heat. Second part, name the material used for making a calorimeter. It is copper, metal, and it is the thin sheet of it. Why is calorimeter made up of thin sheet of the above material? Answered in 2. Now, what does the thin sheet do? Thin sheet decreases the heat capacity of the calorimeter. Thus, it takes negligible heat from its contents to acquire the temperature of the contents. Question 9b. The melting point of naphthalene is 80 degrees C and the room temperature is 30 degrees C. A sample of liquid naphthalene at 100 degrees C is cooled down to the room temperature. Draw the temperature time graph to represent this cooling. In the graph, mark the region which corresponds to the freezing process. So let us look at the graph. We have the y-axis on which we have the temperature, and on x-axis we have time in seconds. Here it is in degrees C, and we have marked the room temperature 30 degrees C, and the freezing point is 80 degrees C, and that is also the melting point for solid naphthalene, and the temperature of the liquid naphthalene is 100 degrees C. So we'll have from A to B it will cool in liquid state, B to C it will freeze at 80 degrees C, and then from 80 to 30 it will be now in solid state, but it will be lowering the temperature. And so we write over here region that corresponds to freezing process is BC. 9C. 104 grams of water at 30 degrees C is taken in a calorimeter made of copper of mass 42 gram. When a certain mass of ice at 0 degrees C is added to it, the final steady temperature of the mixture after the ice has melted was found to be 10 degrees C. Find the mass of the ice added. Specific heat capacity of water is 4.2 joule per gram per degree C. Specific latent heat of fusion of ice is 336 joule per gram. And specific heat capacity of copper is 0.4 joule per gram per degree C. So, you will see that the heat gained by the ice is equal to heat lost by water and calorimeter. So, we will say at equilibrium, according to principle of calorimetry, heat gained by ice is equal to heat lost by water plus calorimeter. Now heat gained by ice at 0 is going to melt into water at 0, so it will have MLF, that is mass into latent heat of fusion, plus when ice has melted into water, it became water at 0 degrees C, and now it's going to become water at 10 degrees C because resultant temperature is 10 degrees C. It will have mc delta T as the heat required for that change, which will be equal to, for heat lost by water, it will be m1 c1 delta T1, plus for calorimeter it will be m2 c2 delta T1, because both of them will have the same change in temperature. So we will have M multiplied by LF, which is 336, plus M into SHC of water is 42 upon 10, multiplied by the rise in temperature is 10 degrees C, because from 0 to 10 degrees is the rise in temperature. Now we come to water. Water, the mass is 104 grams, multiplied by SHC is 4.2. So I'll write 42 upon 10 into temperature difference is from 30 up to 10, which is 20, plus the mass of the copper calorimeter is 42 gram, multiplied by its SHC is 0.4. So we will write 4 upon 10 multiplied by delta T is the same as water. We'll cancel the zeros, and here we will have 336m plus 42m equals, here this becomes 208 multiplied by 42, and we get 8736, plus here 8 multiplies 42, so 8 2's 16, carry 1, 8 4's 32 and 1 33, so we get 336, and so we will have out here, when we add this, 378m is equal to 9072. And now let's continue out here. Therefore m will be equal to 9072 upon 378. Now these are 3 times multiples, and you will get your answer as 24 gram. So the mass of ice should be 24 gram, and that is our answer. Question number 10a. Draw a neat labeled diagram of an AC generator. This I do not want to draw just now because you already have it from the textbook. It's a simple diagram, and your teacher must have taught you how to draw this diagram. So you can draw this on your own. We come to 10b. Define nuclear fission. Now here as well, we will write the definition quickly. So we write the definition. It is the process by which a heavy nucleus is split into 2 light nuclei by bombarding it with slow neutrons. Now we come to the second part. Rewrite and complete the following nuclear reaction by filling in the atomic number of barium and mass number of krypton. So now we'll call this as X and we'll call this as Y, and we will show the working here that 92 plus 0 will be equal to here X plus 36 plus 0, and so you will see that 92 minus 36 is equal to X, and so your X is equal to, so here we have the X value which is the atomic number of barium, is equal to 56. And that becomes your answer 1. Let us look at the mass number here. For the mass number 235 plus this 1 will be equal to this 144 plus y plus 3. And so 236 is equal to 147 plus y. So y will be equal to 236 minus 147. And so y is equal to 89. And so you will say that mass number of krypton is 89. And that is our answer. Now we come to 10C, which is the last question. We have so far solved each and every question. You are expected to solve only 4. But let us look at this 10C now. Let us come to question 10C. I have drawn the diagram here of the circuit. This is the cell with its positive here and the negative here. When the key is shut, the current will flow like so. It will be from B to A, and we have this key over here. So it's going to be north to south. So we have north to south, and we have the compass needle which is drawn here. It is below this conductor, which means the conductor is over the compass needle. It's over the magnetic needle. So the current is going from B to A, means from north to south, and the conductor is over, and so the magnetic needle is going to be deflected to east. So we have our question 1 saying, what will be the direction of deflection here of the magnetic needle? So it will be east, since the current is in north-south and it's over the compass needle. Part 2 told us to explain why was the deflection. So the reason why is when the current flows through AB, a magnetic field is developed around it. This field and the magnetic field of the needle together produce a force which deflects the magnetic needle. Then we come to the third subpart. In the third subpart, the deflection of the magnetic needle, if the compass needle is just above it, what will happen? The deflection will be reversed, and so now it will be deflecting to east. And the fourth subpart, name a device which is based on this principle, and that is an electric bell, because it is based on the magnetic effect of an electric current. And so we have come to the end of this paper. This was Science Paper 1, that is Physics Paper 1 of the Board Examination 2019 paper. I hope those who have appeared, they have understood how it had to be written, and they will be able to gauge how much they will now secure in this examination. And those who are going to appear for 2020 board examination and in future, I hope you have understood how to write the answers, how to present your work, how to write the give reasons, how to solve the numericals, and I hope that all of you will do exceedingly well, much more than what you have already been receiving. So I hope that all of you do extremely well, and so all the best for your future. Thank you for watching.